speakers, Hershil Patel. He's the head of energy and the environment at the Department of Education. He's the member of senior management team responsible for setting the standard for school buildings. So Hershil's presentation is the relationship between school users and the ventilation. So I'm over to you, Hershil. Thank you.
Thank you. Is my screen sharing? It is great. Well, it's great. It's great to be here, and I really appreciate the invite. Look, I'm not an academic, so it probably won't be very technical, this presentation. But I thought when I was invited to speak, I thought long and hard about, you know, what should we talk about. And I think it was really important to sort of try and raise the awareness and certainly the challenges that we have in a school setting. So just a little bit about myself personally. So I'm an engineer. I've come from private sector and been at the DfE for about 2.5 years. As it was said in my introduction, my team is responsible for setting the standards for school buildings, and ventilation very much falls into that remit, and particularly things like Building Bulletin 101. And then with COVID, we've done a number of projects which I'll touch on in this presentation to look at, you know, what the data is showing, but then also very, very importantly, how do we apply this to a school setting? What are the challenges we have in a school settings? Because change doesn't really happen until people start to implement it, so that they can say what it want and what the benefits will be. But if people aren't going to do it, we're not going to move forward in a school setting. And I'll probably talk quite passionately about ventilation because it's certainly something I've been doing for a while. But you know, we've never really had a platform as great as this, if there ever was a silver lining under this pandemic, to talk about ventilation as we do at the moment. So just very quickly, the team I sit in within the DfE, I thought it'd be nice just to share where I sit. So the team I sit in is the design team, and we're mainly made up of architects and engineering professionals. Some have been around for 40 odd years, and some of which have recently just come in. So we've got a very broad range of expertise across those disciplines, and we've been around in one form or another since 1947. And like I said, a core part of our role is setting the standards for school buildings, and that very much picks up on things like Building Bulletin 101, and obviously the big things at the moment around energy and carbon and climate change and how we address that. So our priorities within the team have to be very, very holistic. So we're very conscious that looking at one thing will have an impact elsewhere, not just from a technical perspective, but also from a policy or school operational perspective, etc. So the interrelationships between all of these different areas are really important to us, and we have to manage these because, like I said, there could be unintended consequences when we set a policy out from one area to another. So we found through our post-occupancy evaluation that actually some of the areas which we're a bit unclear about is humidity, temperature, ventilation and air quality, and that very much links in with the COVID side of things. So whereas all the other things are probably a little bit easier to measure, which makes it from a policy making perspective and data collection perspective slightly easier, but those sort of 4 items there are slightly more difficult. And I know that there's sensors and things that we can put in, but it's also around, you know, how do schools use this? We've got a broad range of stakeholders, everything from academics supporting us in policy making all the way through to sort of, you know, head teachers and teachers of classrooms, and how do they use those things to actually impact their environment to make it better for the best possible learning outcomes. And I won't go into detail on everything else, but just on the left and right, we've got all the positive impacts of creating good, healthy environments, and all the things that all the negative impacts from poor environments. And then we've got this slide here. So this slide is just showing, it's trying to share, you know, the extent of our estate and how varied it is. And we've got so many more graphs and charts showing things. I thought this one was just the easiest one to explain, really. So we've got a very, very varied estate, and this makes it challenging when developing our policy. So picking on COVID and ventilation, we recognise that we've got everything from our new builds which have MVHRs or NVHRs, so natural ventilation with heat recovery, or mechanical ventilation with heat recovery, through to natural ventilation and uncontrolled ventilation in our schools. So sometimes it becomes quite, I wouldn't say difficult, but we just have to consider those different environments and those different settings and how we set our policies. And then we also collect a load of data around condition data, which tells us the condition of our estate. So it's a 5-year program where we send building surveyors around to do non-intrusive surveys of elements of the building and the sites to see what the condition is, and that helps us to establish funding required to sort of address condition. But the thing that's been missed out of all of this, and when we talk about funding schools, is it's so heavily condition based. We sometimes miss those environmental benefits or those healthy benefits, which again is harder to quantify sometimes. But even from an energy efficiency perspective, we don't have as much data on that as we do around condition. We've got loads of information around condition. And then this slide is really to show, so we've done loads of post-occupancy evaluations. We've done them on our new builds, existing buildings, zero carbon schools that we apparently built 10 years ago. I think only one of 10 of those were zero carbon. So we've got lots and lots of information. And I think when we talk about ventilation, we just have to have a look at our schools, and we can very quickly recognize some of the challenges we face within our school estate. So the top 2 images up here are just showing typically, blinds in front of open windows, which I think is a classic thing we get in a school scenario. We have openable roof lights that were blocked out for whatever reason from the schools. This isn't really about ventilation, but it's just to give you an example because I couldn't find the image, but I've seen bookcases in front of things like thermostats and ventilation units, or so the occupants of those rooms don't necessarily have access to the controls where for example you might have mechanical control. And then the bottom 2 examples is very typical of I mean, I wouldn't say it's a majority of it, but we certainly see it time and time again where there's restrictors on windows, and this one, although it's on a restrictor, it's locked, so that occupant can't open that window. And you've got the classic windows painted shut, and I've grayed it out of it because it's not actually one of our images. I've had to steal it off the internet, but we do see that time and time again where windows are painted shut. So access to ventilation, as much as we can set policies and standards around physically accessing ventilation, is sometimes very difficult. And then you've got the sort of wider challenges around air quality, external air quality, and schools adjacent to sort of A roads or M roads in some cases. And there's a very grey area of where does that responsibility lie? Where does external air quality sit? Does it sit with DEFRA? Does it sit with DFE? Does it sit with Environment Agency, Department for Transport? There isn't any clear direction at the moment. This is me criticising the government. I'm just being open about we're unclear about this. And then the last image is just, I'm not sure if you can see it, but it's a filthy filter. And again, it's what are schools? So this is where we have mechanical ventilation, but schools' ability to manage their system. So, we know mechanical ventilation or controlled ventilation is great, but there is this maintenance side of things, and are we putting the right? We ask ourselves the question: are we putting the right systems in for the level of ability of that school to manage that asset? And we see it time and time again. In year 1, I mean, energy is a good example. In year 1, we always see our sort of energy targets met. Year 2, 3, 4, and 5, they start to drop off, and by year 10, they're nowhere near where they were in year 1. So obviously, there's a number of factors that play into that, but a lot of it probably has to do with management of the asset. So it's just to share the challenges that we found through our post-occupancy evaluation of what schools face, really. So again, what are we finding? And this is really around the user needs here. And I've heard, I've spoken to plenty of ventilation specialists and colleagues across the department and private sector. I think some of the key things that we're finding is limited understanding of what ventilation is, and also the difference between CO2 and carbon dioxide and carbon monoxide. I think I heard a colleague say to me, a friend within private sector say to me, there was a school that evacuated because they had CO2 sensors, in the school, and it went into a red zone, or the red light came on, and they thought it was carbon monoxide and thought it was incredibly dangerous, and evacuated the entire school. So what we're finding from that is the guidance or anything we produce has to be extremely clear and concise. Again, we've got varied stakeholders and users to our policy, so it has to be incredibly simple, but not so simple it doesn't create the right change that we need to. We've got, every time I speak to schools, and my wife's the head teacher in a school, we've got huge amounts of competing priorities within the school setting. So if I'm talking to a school leadership team around the benefits of ventilation or energy or anything to do with the sort of building and the asset, it's quite low on their priority list. I mean, it is growing in some aspects, and ventilation is growing, particularly given the platform we've got at the moment. But it's things like safeguarding, it's things like the delivery of education, et cetera, that sort of supersede some of these really important issues. So it just shows how important some other things are. And the last one is extreme behaviours, and I've called it evacuating a classroom just because it links to the sort of image on the right. And I'm not sure if anyone's seen that, but I think it was a really positive thing that's happened, which is where the charity around long COVID kids, they've been putting CO2 sensors in. And when it exceeds a threshold, and I'm not sure what the parts per million number is on that, but when it exceeds a certain threshold, they evacuate the classroom. I think from a DFE perspective, that's quite an extreme scenario to evacuate a classroom because CO2 levels have been exceeded. We would envisage more of a hierarchy type solutions, like opening windows or purging spaces, etc. From a DFE perspective, I think evacuating classrooms every time CO2 levels go up is probably it's quite extreme for us. It's not, certainly in a secondary school setting is probably not something in a position would be promoting anyway. So again, it's about this behavioural stuff and how people interact and that relationship between ventilation and occupants and how they perceive it, the same way that we currently have with heating. I think we're a lot better with heating than we are, say, with ventilation. And then I just wanted to share some data. I've got my slides slightly the wrong way around, so I'm going to go on to this one first. But we've started a project with NHS Track and Trace, and effectively it's called CIVOS, which is the change in ventilation of schools, monitoring CO2. And we might have some project partners on the call at the moment, so please feel free to jump in and add to this. But basically, the idea of the project was to establish if CO2 monitoring can be used to manage ventilation in light of COVID. And so we set up this pilot study with NHS Track and Trace. And the pilot was really to explore whether classroom ventilation changes once we put in in-room CO2 indicator displays, and then explore the potential links of the change in that ventilation related behaviour, and then the management of opening uncontrolled things like windows and doors. So the so within this group, sorry, I've lost track slightly. So DFE, one of the key stakeholders, and obviously NHS Track and Trace, and also Kath Noakes is very much involved in the project, as is Dr. Henry Burridge from Imperial College, who's helped us do some of the mathematical analysis. But effectively, what we've done in this project is we've taken 40 CO2 sensors, and we've taken 40 CO2 sensors which are blind, and we've taken 40 in-room monitors just to have a look across 4 schools somewhere in the north. They're all uncontrolled ventilation, and we've put them in each room. So the intent of the trial was to put in blind monitors just to see how schools operate and what their sort of interaction is with ventilation, and then following a period of sort of baseline data, put in a sort of traffic light monitor, as you could call it, I guess, and see whether, with guidance, to see whether behaviours change and whether there's an improvement in ventilation. Now, all of this was supposed to be done during the winter period. However, with school closures, we very quickly moved out of that winter period. And unfortunately, we're not going to be able to get representative data of a winter period, but we are still getting some really useful data through at the moment. I'll just go back a slide. So off the back of that project, Dr. Henry Burridge did some really great work around looking at seasonal variations in airborne infection risk. And the DfE supported this by providing and linking Imperial College up with the CO2 data of recently built schools. So we were able to get a lot of data around controlled ventilation. So these schools, I think, typically had natural ventilation heat recovery units. So they're basically boxes with fans in them, ducted to outside. And the study found that the airborne infection risks are likely to vary significantly. Sorry, I think I'm on the, no, that's right, sorry. So the study found that airborne infection risks in schools are likely to vary significantly with seasons, and purely based on changes in environmental conditions. The expected levels of secondary infection risk in winter is nearly double that of summer here. And while the study, while this study identified, what limited, the study helped us to identify we had a limited access to uncontrolled data. We needed to try and understand uncontrolled settings a bit better. And also we didn't know in a school setting what the behavioral relationship was between a user and ventilation rates. And it does vary from school to school. And then sort of jumping on from that CIVOS project, we started to extract some data, and then looking at the two graphs and the data that we're extracting from is looking at the two graphs. It shows that the sort of variation in carbon dioxide across two rooms with blind sensors in them, and again in an uncontrolled setting, so just where they have open windows. So this data was taken from when schools reopened again from the 8th of March to just before the Easter break. And the red horizontal lines show that the marked daily average concentration of CO2 as defined by Building Bulletin 101, which is the school standards for ventilation. And then both the classrooms, assuming all else is equal, assuming all things are equal, the data plotted shows that the left-hand figure illustrates classrooms with higher ventilation rates, with the daily averages below 1,000 parts per million, whilst the right-hand figure shows lower ventilation rates, and well above 1,000 parts, in some cases above 1,000 parts per million is the daily average. And then the second pair of graphs at the bottom there shows the measurement of CO2 concentration plotted against this corresponding internal temperatures recorded within classrooms for the same duration of the figures above. And then the data is marked by the crosses with circles highlighting the data within the occupied period only. So when students and staff are in there. And in both classrooms during the occupied period, there's an 85% correlation coefficient between CO2 and temperature. And I think the left-hand graph shows that the data from the classrooms with relatively high levels of ventilation, which are being measured, remain above 18 degrees during that occupied period, but never really exceed 22 degrees. And I think conversely, the data on the right with the lower ventilation rates show higher temperatures for all of the CO2 measurements, and are in the range of between, sort of, as I said, 1,000
we have
to
2 minutes
1,600.
left.
Okay, well, I'll move on then. Oh, that was it. Sorry. Oh no, there's this last one. Apologies. So just very quickly, so what we're finding at the moment is we haven't got data to show any winter ventilation scenarios, but what the data is showing to us at the moment, again coming back to what are we going to tell schools if we choose to put CO2 monitoring in our guidance. And I think this chart sort of shows it really well. And the chart shows the data of CO2 parts per million concentration in a room, with the red line showing the daily sort of running average, across the day, and the blue line shows the instantaneous values. I think so, sticking with the theme of that behavior and how people are going to interact with things, and that extreme example of where schools evacuated because it went above the threshold. I think what this shows is the daily averaging gives us an advantage in that it will stop reactive behavior. It will stop people either evacuating classrooms or constantly opening and shutting windows, so they'll engage with that ventilation better. So anyway, I'll end there, and I guess on the next slide, I was just say, what's next for the DfE? And I know this was a very academic discussion, but it was really around saying, what do we need to do? How do we actually implement that change and that relationship with behavior? And I think, if we don't do anything now, we'll probably lose that opportunity at some point in the future, because I think COVID has really given us that platform to talk about ventilation. The very important topic of ventilation. So anyway, I'll leave it there. Sorry if I've run over.
Thank you very much. Thank you for the presentation on the school ventilation. I looked at the Q&A box. It seems that nobody asked the question. If I ask one very brief question, and if you can answer, will be brilliant. So I look at your slides, January and July, the risk mentioned, the July is lower. Is that because in the July, people in the school classroom, the natural ventilation was used? Is that because of this reason?
Yeah, I would suspect, so they were both controlled, so they basically got mechanical ventilation in them. But I suspect in July what happens is because the temperature increases, internal room temperatures increase, you naturally open your windows more, and you'll probably have your mechanical systems running as well.
Okay.
So you probably get higher levels of ventilation because of increased room temperatures.
Thank you very much. Thank you for thank you, Hershil, for your fascinating presentation. This is very, very interesting. Thank you.